students, warm welcome to the module on buffer solution. In this module, we are going to discuss about what is meant by a buffer solution and what are the different types of buffer solutions. Let us start our discussion by thinking about the pH of a solution. What is the pH of a neutral solution? Yes, it is 7. What is the pH of the acidic solution? Yes, it is less than 7. What will be the pH of a basic solution? Yes, it is greater than 7. And my question is, what will happen if we add an acidic solution to the neutral solution? Yes, its pH will decrease. And what will happen if we add some basic solution to the neutral solution? Yes, its pH will increase. I will show a video. You have to observe or watch the video and identify what is happening when small amount of acid or base is added to the distilled water. You found that in one beaker there is one substance that is called a buffer is added, and you found that there is no change in the pH or color of the solution. And in the another beaker you found that there is a change in the color, and in that beaker there is no buffer is added. So here you understood that some substance can resist the change in the pH of a solution. Such substances are called buffer solution. So what is meant by a buffer solution? Yes, a buffer solution that lessen the impact of an addition of acid or base. So we can define the buffer solution as the solutions which resist the change in the pH of a solution when small amount of acid or alkali is added to it. Buffer solutions are of two types: acidic buffer and basic buffer. I will give one example for each one of them. A mixture of acetic acid and sodium acetate act as a acidic buffer around a pH of 4.75, and a mixture of ammonium chloride and ammonium hydroxide act as a basic buffer around a pH of 9.25. First, we shall consider the first example, that is mixture of acetic acid and sodium acetate. You have to identify the nature of acetic acid and sodium acetate. Yes, everyone know that acetic acid is a weak acid and sodium acetate is a salt. How this salt is formed? This salt is formed by the combination or reaction between a weak acid with a strong base. Which is the weak acid in the preparation of sodium acetate? Yes, it is acetic acid. And which strong base is involved in the preparation of sodium acetate? Yes, it is sodium hydroxide. So sodium acetate is a salt of weak acid with a strong base. So what we can say about this mixture, that means acetic acid sodium acetate mixture? Yes, it is a mixture of weak acid and a salt of weak acid with a strong base. So an acidic buffer is said to be a mixture of weak acid and a salt of weak acid with a strong base. Similarly, can you identify an example or how we can prepare a basic buffer by considering the second example? That is, the second example is example of ammonium chloride and ammonium hydroxide. Here also you can find that there is a weak base and a salt. Here the weak base is ammonium hydroxide and the salt is ammonium chloride. What is the importance of ammonium chloride? Ammonium chloride is formed by the reaction between a weak base and a strong acid. Which is the weak base? The weak base is ammonium hydroxide. And which is the strong acid? That is HCl. So, ammonium chloride is a salt of weak base with a strong acid. So, we can say that a basic buffer is a mixture of weak base and its salt of strong acid. So, these are the two types of buffer, an acidic buffer and a basic buffer. Now, we shall derive the relationship between pH and pKa. What is pH? pH is potence of hydrogen, and pKa, Ka is dissociation constant of a weak acid. So, we are going to derive the relationship between pH and pKa. For this, you have to write the dissociation equation of a weak acid. A weak acid can be represented as Ha. So, the dissociation equation is Ha plus H2O reversibly gives H3O plus A minus. Now, you have to write the expression or equation of dissociation constant of weak acid, that is Ka. What is the dissociation constant Ka? Ka is equal to molar concentration of H3O plus into molar concentration of A minus divided by molar concentration of Ha. On rearranging, we will get molar concentration of H3O plus is equal to Ka into molar concentration of Ha divided by A minus. You have to take the logarithm. So, what we will get? Logarithm of H3O plus equal to log of Ka plus log of molar concentration of Ha divided by molar concentration of A minus. We know that negative log can be taken as P. So, negative log of H3O plus is equal to pH and negative log of Ka equal to pKa. So, our equation become pH equal to pKa plus log of A minus divided by molar concentration of Ha. Or we can say that pH is equal to pKa plus log of molar concentration of conjugate base divided by molar concentration of weak acid. This expression is known as Henderson-Hasselbalch equation. We know that here the acid is a weak acid and it ionizes to a very little extent, and the concentration of Ha is negligibly different from the concentration of acid taken to form a buffer. Also, most of the conjugate base, that is molar concentration of A minus, comes from the ionization of the salt of the acid. Therefore, concentration of conjugate base will be negligibly different from the concentration of salt. Thus, the equation takes the form pH is equal to pKa plus log of molar concentration of salt divided by molar concentration of acid. Similarly, you have to try to write the equation for pH of the buffer of weak base and salt of weak base with a strong acid. And we know that the equation becomes POH is equal to pKb plus log of molar concentration of conjugate acid divided by molar concentration of weak base. So, in this module, we are discussed about buffer solution, various types of buffer solution, and Henderson-Hasselbalch equation. Hope you all understood about all these things. Thank you, dear students. Thank you. Meet in the next class.